Hello everyone. In this video, I'm going to talk about a technique called Agarose gel electrophoresis. It is a widely used laboratory technique and is used to separate DNA molecules based on their sizes. First, we'll be defining what is gel electrophoresis, then we'll see the principle on which this technique is based on, then we'll see the chemicals required to carry out this technique and the function of those chemicals. Then comes the protocol by which this technique can be carried out. Then at last we'll see its applications. So look at this word electrophoresis. Here electro means electric field and phoresis is a Greek word which means migration. In this context, it will be migration of molecules. When the molecules migrate, they can be separated based on their charge, mass and shape. Once they get separated, we can characterize them. So, gel electrophoresis can be defined as a separation and characterization of the molecules in a mixture based on their charge, mass, and shape under the influence of an electric field using the gel as a medium. If we use agarose for the preparation of gel, it is called agarose gel electrophoresis, which is used to separate DNA molecules. If we use polyacrylamide for the preparation of gel, it is called polyacrylamide gel electrophoresis and it is used to separate protein molecules. Now, why is agarose used to separate DNA molecules and not proteins? Or why is polyacrylamide used in the separation of protein molecules and not DNA molecules? When we use agarose for the preparation of gel, the gel that is formed has large pores. So that means it has less resolution. So the large DNA molecules are able to pass through this gel with large pores. Polyacrylamide gel has small pores, that means it has high resolution. So small molecules like proteins are able to pass through these small pores. Now let's see the principle on which this technique is based on. As we know that DNA is negatively charged, if it is kept in an electric field, it will migrate from a negative electrode to the positive electrode. So the DNA molecules which are smaller in size migrate faster and move towards positive electrode faster. The DNA molecules with large size, they migrate towards positive electrode a bit slow when compared to the small size DNA fragments. So they remain near the negative electrode. So this differential migration is the basis for their separation based on their sizes. Now, if we want to carry out this technique, we will be needing TAE or TBE buffer, ethidium bromide, DNA loading dye, DNA ladder, DNA samples, and agarose. Here in TAE and TBE, T refers to tris, A and B refers to acetate and borate respectively, and E refers to EDTA. Tris is a strong base and acetate and borate are acids. So the combination of tris acetate and tris borate provides alkaline condition of pH 8 to 8.5, which is useful in preventing DNA hydrolysis. Now there is an enzyme called DNase which is able to hydrolyze DNA. This DNase enzyme requires magnesium ion. So the function of EDTA is to chelate this magnesium ion, thereby rendering DNase non-functional. So EDTA helps in preventing DNA hydrolysis as well. So the buffer is used in maintaining pH of the medium. The buffer controls the net charge of the water molecule. It provides a liquid medium for the migration of DNA in the gel and it prevents DNA hydrolysis. Ethidium bromide is known as a nucleic acid tagging agent or an intercalating agent. Now, as DNA is colorless, it is not possible to visualize these DNA molecules with the naked eye. So, this ethidium bromide intercalates itself in the DNA molecule and when it is kept under an UV light, it fluoresces. It gives orange fluorescence. So, with the help of ethidium bromide, you can actually visualize DNA molecules. If the fluorescence is more, that means there are more number of DNA fragments as it appears as a thick band. DNA loading dye has bromophenol blue and glycerol as its main components. When you load the DNA sample in the wells, It is not possible for you to monitor its migration as it is colorless. Bromophenol blue gives a bluish color to your DNA sample, so that it is easy to monitor the DNA migration. And glycerol gives density to your DNA sample, so that it doesn't leak out of the wells. The DNA loading dye is also useful in monitoring cross contamination, sample overflow, or if there's any leakage of sample. DNA ladder has DNA molecules of different sizes. So, this DNA ladder can be used as a reference to know the size of your unknown DNA sample. Agarose is a polysaccharide that is obtained from a red algae. It is useful in making your agarose gel. It is used in the range of 0.7 to 2%. If low percent of agarose is used, the gel formed has large pores, which is useful in separating large DNA. If high percentage of agarose is used, the gel formed has small pores, and it is useful in separating DNA of small sizes. Let's see the protocol involved in carrying out this technique. First, you have to weigh the agarose powder and add it to the TAE or TBE buffer. Boil this mixture and let this cool down. Once this cools down, add ethidium bromide and pour it in the gel caster, keeping the comb at one end. The comb helps in the formation of wells in the gel. Now let this liquid gel solidify. Once it gets solidified, keep it in the electrophoresis chamber. Now fill the chamber with the buffer and then remove the comb. Now here the same buffer that you have used for the preparation of gel has to be filled in the chamber. Now load your DNA samples into the well after mixing with DNA loading dye. Now connect this setup to a power pack and turn on the power at 80 volts to 150 volts. Once your DNA samples migrate to the positive electrode, turn off the power pack and visualize the gel in an UV trans illuminator. Let's see its applications. This is useful in estimating the size of DNA molecules and analyze PCR products. It is useful in restriction mapping of cloned DNA and separation of restricted genomic DNA before performing southern blotting, and separation of restricted genomic RNA before performing northern blotting. It is useful in resolving different fragments of DNA. Hope this video was useful for you. If you liked this video, please share it and subscribe to my channel.